हेलो एवरीवन, वेलकम टू बायोमिक्स। होप यू डूइंग वेल। सो आज के इस क्लास में हम डिस्कस करने वाले हैं अबाउट द लॉटका वोल्टेरा मॉडल। सो जब टू स्पेसेस प्रेजेंट रहते हैं, व्हेन देयर आर टू स्पेसेस प्रेजेंट इन सम ऑफ द एनवायरनमेंट, सो देयर इज अ competition between them. So after the competition there needs to be some result, that means someone has to win if there are spaces A and spaces B. Suppose for example there are two spaces, like there is spaces A and there is spaces B. Among these two spaces, what happens that there is a competition, and this competition can be for different things, like it can be for food, it can be for food, it can be for mate, it can be for space, it can be from any reason. The competition between the two spaces can be from any reason. So after the competition someone has to win. So who will win? How it will be decided? So it will be decided among that who is more strengthened. Okay, so who is winning? It is decided, it is being decided by this Lotka Volterra model. So when we talk about the Lotka Volterra model, so here the two things are coming in case of the Lotka Volterra model. The first is the competition model. Okay, the next is the predator prey model. Okay, so first we will discuss here in this class, we will discuss about the competition model. That means how two spaces are competing and how this Lotka Volterra model is telling that who is going to win, how this model will describe that who is going to win. Okay, so when we discuss here about the spaces, so here the Lotka Volterra model, what it is telling? It is telling that who is going to win after the competition. Okay, so in this case who is playing the role? The spaces are playing the role. So here there are two kinds of spaces. His interaction, competition is taking place. So here two types of competition, that is interspecific competition is taking place, or else intraspecific competition. Okay, so what do you mean by interspecific? Interspecific means the competition is taking place between two different spaces. Okay, suppose spaces A is present, some of the individual of spaces A is competing with some individual of spaces B. So the competition is between spaces A and spaces B. That is known as interspecific competition. Okay, the next is the intraspecific competition. Intraspecific competition means the competition will take place between the same spaces. Suppose spaces A is present. Okay, when the spaces A will compete with its own spaces, that means A will compete with A. In this case it is known as intraspecific competition. Okay, so this competition can be for different things, like it can be for mate, it can be for space, it can be for food, it can be for defense. Okay, so now the next thing which we will discuss here about some of the terms, like what is K value or carrying capacity. So what do you mean by K value? The K value is the maximum population of spaces which a environment can handle. Suppose this is a space, and for this space the carrying capacity is there for spaces 1. So for spaces 1, here only 1000 spaces can live. Okay, and here there is another environment. For this, the spaces 2 which is present here, 500 spaces can be present over here. So the carrying capacity for spaces 2 in this environment is 500, and in this case the carrying capacity for spaces 1 is 1000. Okay, so the next term is the isocline or zero growth isocline. So while discussing here, we will discuss about what is the isocline or zero growth isocline. Okay, so the next thing is the growth curve. So when we discuss about the growth curve can be again of two types, that is the S-shaped curve and J-shaped curve. Okay, the S-shaped curve is for showing the logistic growth, and the J-shape curve is for the exponential or geometric growth. Okay, so the J-shape thing which is present, it is exponential means it is continuously growing, it does not have any limit. So what happens in the, from this J shape only the S phase is coming. Initially the S phase which is present, it is initially in the J phase condition. So what happens in the J shaped, what happens, the species which is present, it is exponentially growing, it does not have any limit for its growth. Okay, but in case of SA, for some period of time it is exponentially growing, that means it is showing the J-shape curve, and after that it is being steady, it is going into the steady phase. Okay, that is the reason it is showing the S-shape curve. And this, the Lotka Volterra model which is present, it is coming upon the logistic growth. Okay, so what is this logistic growth or the S-shape curve? What is its formula? The formula for this logistic growth is dn by dt equals to Rn k minus n by k. Okay, this is the equation for the logistic growth. And the Lotka Volterra model which is present, it is being defined, it is being done by this equation. So by discussing, while completing this all things about this Lotka Volterra model, we will understand how this logistic growth formula is being applied in this Lotka Volterra model. Okay, so the next thing, so we have already known about what is interspecific competition and what is intraspecific competition. Okay, so here there are two competition, interspecific and intraspecific. So interspecific means between two different spaces, the competition is between two different spaces, and intraspecific means the competition is between its own spaces. Okay, now next thing, this thing already we have discussed about the J-shape curve and the S-shape curve. Now the term alpha 2-1 or alpha 1-2, what does this means? So here, for example, we will see that there is species 1 is present. So the species 1 is present and species 2 is present. So when species 1 is inhibiting the species 2, so in this case, or it is dominating the species 2, so in this case it is known as alpha 2-1. That means 1 is showing the inhibitory effect on 2, species 2, or this alpha 2-1 which is present, it is also known as beta. The next case, species 2 which is present, when it is showing the inhibitory effect on species 1, it is known as alpha 1-2. That means species 2 is showing the inhibitory effect on species 1. So it is also known as alpha. Okay, so here you can see here alpha 2-1 is known as beta, in which effect of species 1 is on species 2. Here the species 1, effect of species 1 is on species 2. Next, effect of species 2 on species 1. Here the species 2 is present and the species 2 is showing the inhibitory effect on species 1. So it is known as alpha. Okay, so I hope you are clear with these things. Now here you can see alpha 2-1. What does this alpha 2-1 say? Tells that it is a competition coefficient representing inhibitory effect of species 1 on species 2. Species 1 is showing the inhibitory effect on species 2. Next, the alpha 1-2. Alpha 1-2 means competition coefficient representing inhibitory effect of species 2 on species 1. So, species 2 on species 1, it is showing the inhibitory effect, which is known as alpha 1-2. I hope you are now clear with these terms, like what is alpha 2-1 and what is alpha 1-2. Alpha 2-1 is known as beta, alpha 1-2 is known as alpha. Okay, now next thing. So here there are two things, like case 1 we will see what it is telling. When alpha 1-2 which is present, it is less than 1. What does this indicate? That means this alpha 2 1, 2 1 means 2 is having the inhibitory effect on 1, so it is less than 1. That means the inhibitory effect is less. Okay, because it is less than 1. Next is case 2, that is alpha 1 2 which is present, it is greater than 1. So what happens in this case? The species 2 which is present, it is showing the inhibitory effect on species 1, and its effect is more because it is showing it is higher than 1. So here the effect is high. Okay, so let us see what this statement is telling. Alpha 1 2 is less than 1 if alpha 2 is showing the inhibitory effect on 1 and it is less than 1. That means the effect of species 2 on species 1 is less than the effect of species 1 on its own member. So in this case what happens? The effect of species 1 is more in its own species. Okay, what happens? So what happens in this case? The inhibitory effect of species 1 in its own member, in its own species is more. That means here what kind of competition is taking place? Here the competition which is taking place is the intraspecific. Here interspecific competition is not taking place because here the species 2 which is present, it is showing less inhibitory effect on species 1. But so here in this case what happens? The species 1 which is present, it is showing the competition between its own species. So the intraspecific competition is more in this case. Okay, so here, so in this case 2 what happens? Alpha 1 2 is greater than 1. That means species 2 which is present, it is showing the inhibitory effect on species 1 and the effect is more. So in this case interspecific competition is more. That means the competition is between the species 1 and the species 2. Here the species 2 which is present, it is showing the inhibitory effect on species 1. Okay, but in the first case, that is the alpha 1 2, when it was less than 1, in this case the 2 species 2 in the species 1 was showing the less inhibitory effect, due to which it is showing the intraspecific competition. Means the species 1 is competing with its own member. Here the 2 is species 2 is not affecting species 1, but in the case 2 the species 2 is keeping the inhibitory effect on species 1. So here the interspecific competition is more as compared to the intraspecific competition. Okay, now here you are having two conditions. Like, can you tell me which species will win in the first case? What happens in this first case? Alpha 1 2 is greater than alpha 2 1. So here what happens? The species 2 which is present, it is showing the inhibitory effect on species 1 and it is greater than alpha 1 2. That means alpha 1 which is showing species 1 which is showing the inhibitory effect on species 2, it is less. So here who will win? Here species 2 will win, because here the species 2 which is showing the inhibitory effect on species 1 is greater in this case. Okay, now the second condition, alpha 2 1. Alpha 2 1, that means species 1 is showing the inhibitory effect on species 2 and it is greater than alpha 1 2, which is species 2 is showing the effect on species 1. So here in this case species 1, when it is inhibiting the species 2, it is high. So in this case species 1 will win. Okay, I hope you are clear with these things. Now the next thing, it is about this only the same explanation, and here like you can see here, effect of species 2 on species 1 is high as compared to the effect of species 1 on species 2. So N2 or species 2 will win and species 1 will lose. Here it is the explanation of what we have already solved now. Okay, now we will see how the Lotka-Volterra model, how the Lotka-Volterra model's equation is used, how the logistic growth equation is used in the Lotka-Volterra model. So here you can see this is how the Lotka-Volterra model is using the logistic growth. Like here you can see when the spaces 1 equation for the spaces 1 when it is growing alone. Okay, so it is dn by dt equals to r1 n1, that is it is indicating for spaces 1 into k1 minus n1 by k1, which is same as the logistic growth. Okay, now it is a condition when spaces 1 is growing with spaces 2. Okay, so here we have to write the equation of logistic growth like dn1 by dt equals to r1 n1 into k1 minus n1 by k1. Okay, now there will be a minus symbol added over here. Here it is alpha 1 2. So why this alpha 1 2 is present? Because this is for species 1 and species 2 which is present, it is showing the inhibitory effect on species 1. Okay, and how much number of species is present for species 2, how many number is of how many species 2 is present, that is also deciding that how the effect will be done. So here the n2 is present, okay, by k1. Okay, I hope you have understood this equation. Like for spaces 1, the equation is dn by dt equals to r1 n1 k1 minus n1 by k1. Okay, but when the spaces 2 is growing with spaces 1 now, that means spaces 2 is creating a problem for spaces 1. Okay, so how many population of species 1 is present, it is also dependent that how it will affect. If there is less number of species 2 which is present, then its effect will be low as compared to when the number of population of the species 2 is high. So here k1 r, so here the equation will be when species 2 is present dn1 by dt equals to r1 n1 into k1 minus n1 minus alpha 1 2 into n2 by k1. Okay, now we will see how this things is taking place when there is only species 2 which is present here. See here, this is the condition when only species 2 is present, that is dn2 by dt equals to r2 n2 k2 minus n2 by k2. Okay, so here what happens in case of species 1, here everything was 1 because it was for species 1. Here everything is being done with species 2. Okay, now the second equation is when species 1 is living with species 2. Now species 1 which is present, it is creating a problem for species 2, that means it is species 1 is affecting species 2. So here dn by dt equals to r2 n2 k2 minus n2 by k2 minus, here minus sign will come and here it will come alpha 2 1, that means species 1 is extra here, species 1 is showing the inhibitory effect on species 2 and number of population of species 1. Okay, I hope you have understood these things for species 1 and species 2. Okay, now so the coexistence which is present, it can be of different types. Okay, so here the coexistence, what is the condition when there will be coexistence? Coexistence means two species which are present, they can coexist, that means they can stay in a same place, that is known as the coexistence. So the coexistence will take place when the intraspecific competition is greater than interspecific competition. Okay, so what do you mean by the intraspecific competition is greater than interspecific competition? That means the competition between same species competition is greater than the competition with different species. Okay, then the coexistence will take place, because when the competition will be high between the two different species, then someone will dominate the other. So here the coexistence cannot take place. They cannot stay together. When, what is the condition when they will stay together? When they can coexist? When the intraspecific competition, that means the competition between the same spaces will be high as compared to the interspecific competition. Okay. Now here there are different type of coexistence also. Okay, so it can be stable coexistence and it can be unstable coexistence. Okay, so when the coexistence is stable, okay, what is the condition when this coexistence would be stable? When when both the spaces are weak, then the coexistence is stable, because when one spaces will be weak and the other spaces will be strong, during this case one species will try to dominate the species will try to dominate the other. So here the coexistence cannot take place. Okay, so the stable coexistence is when both the species are weak competitor. Okay, no one is strong in that case. During that time only the coexistence will be stable. Okay, for a long time they can coexist, they can live together. The next condition is the unstable coexistence. Coexistence, that means they are having the ability that they can stay together, but it is unstable. Why it is unstable? Because one species is strong, okay, and the other species is weak. During this time what happens? Here the coexistence cannot take place. So the in case of the unstable coexistence, both species are strong. Here both the species are strong, so here the instability will take place. It will not be stable. In this case one species will win. Okay, but it depends upon the initial condition or the direction of event. The slightest form an unstable equilibrium for coexistence. Okay, so this is how the stable coexistence and unstable coexistence will take place. Next is competitive exclusion. So competitive exclusion, what do you mean by competitive exclusion? In the competitive exclusion, the interspecific competition which is present, it will be higher than intraspecific competition. That means here the competition will be high when between the two different spaces. During this time the competitive exclusion will take place, because now in this case they cannot stay together in the same environment. Okay, so in this case one species is strong and the other is weak. Species 1 wins and species 2 will lose, or species 2 wins and species 1 will lose in case of competitive exclusion. Okay, but in case of coexistence they will try to coexist. Okay, now these were the theory portions which we have already discussed. Now let us come to the graphical type of things. Now here there are two types of equations which are present. Now here you can see species 1 and species 2 when they are growing alone. So the carrying capacity is K1 for species 1 and the carrying capacity for species 2 is K2. But what if these two species which are present, they are growing together? What will be the equation? So here you can see here the equation can be also written as, for K2 it can be written as K1 by alpha 1 2. That means species 2 is affecting the species 1, and for K1 it can be written as K2 by alpha 2 1. That means 1 is showing the inhibitory effect on 2. Okay, and it is in the presence of K2. Okay, so here when we see the graph, here the number of population of species 1 is present, here the number of population of species 2 is present. Okay, so here like this is the isocline line. So in the first slide we were discussing about the isocline line. This is the isocline line. So in this case, in the N1, you can see here the carrying capacity is high for species 1. Okay, so here you can see in case of N2, In case of N2, it is the K1 by alpha 1 2 is high. So here the graph is here. Okay. Now when you join these two things, this is the isocline. Okay. So when we talk about the isocline, what happens? Above the isocline, the species 1 which is present, it will increase. Above the isocline, the things will, sorry, above the isocline, what happens? The species 1 will decrease. Okay. So here it is, so for species 1, this things is only for species 1. Okay. So in this case, this isocline is present, and this is below the isocline things, and this is above the isocline. Okay. Species 1 decreases above its isocline. So above its isocline, it decreases. That means the arrow will be this side. Okay, when it is above the isocline, like here you can see above the isocline, the arrow is towards back side, and below the isocline, the arrow you can see it is in the increasing order. This is for species 1. And for species 2, what happens? The arrow is in the vertical way. Okay, for species 2 it is vertical way, but here we are only seeing for species 1. Okay. Now K1 and N1, species 1 on x-axis. Here it is showing the x-axis. It is only showing for species 1. Now this is the second condition. Second condition is for species 2. Okay. So in case of species 2, here the N1 is for species 1, here the N2 is for species 2. Okay. Here the K2 which is present is high. This is the carrying capacity of species 2. Okay. And here you can see for species 2 it is alpha. Here for species 1 it is K2 by alpha 2 1. In this x-axis you can see alpha K2 alpha 1 2. It is for species 1. And here there is a isocline line. So for species 2, when we see about the species 2, the arrow is vertically. So above the isocline, what happens? The arrow will be in the decreasing way. It will be towards downward sides, and below the isocline it will be increasing, that is in the upward direction. It is when we see about the individual, that is the species 1 and the species 2 individually in different graphs. Okay. So here let us see some other things. So this is the condition when the two species are staying together. Okay. So this x-axis is for species 1 and y-axis is for species 2. In case of species 1, the K1 is high. Here you can see the K1 is high. And here the K2 by alpha 2 1. That means here the 1 is showing the inhibitory effect on 2 is low. And in case of N2, the K1 by alpha 1 2 is high and K2 is low. So this K1 will be joined together. From x-axis and y-axis K1 will be joined. So here there is a isocline for this, and here K2 will be joined from x-axis and y-axis. So here when we talk about the species 1, okay, so for species 1 this is down and this is up. This is up and this is down. And for species 2, what happens? For species 2 here, this is up and this is down. Okay. So for species 2, so what it is saying? It is, this example is for species 1. Species 1 isocline is above. Okay. So here if the species 1 is above, so here the isocline will be towards the downward sides, and if it is for this species, for the species 1 it is down, that means it is increasing, and for species 2 it is up, that means it is decreasing. So in between it will show a line. Okay, so this line is indicating the K1. Okay, so what happens here? The first thing is that about this isocline, so there is a point where we will take, like randomly we will take a point. So in this case, for this species 1, here the point is down, it is below, that means this line will increase. And for the species 2, the line, the point is above, that means it will decrease. So here in between there is the resultant line, where it is showing, indicating that who is going to win. So in this case K1 is going to win. Okay, so here in this case K1 will win. Okay, so from this equation also you can know that who is going to win. Like here in this case you can see that K1 which is present, it is greater than K2 by alpha 2 1, and K2 is less than K1 by alpha 1 2. In both the case K1 is greater. That is the reason K1 is high, or K1 will win. Okay, now let us see the next case. In this case, who is going to win? Like from this equation you can see that K2 is going to win, because higher is the K2. Okay, so in this case, like say here K1, that means this is for species 1. So it is low. So in the x-axis K1 is low, and here you can see K2 alpha 2 1 which is present, it is high. So it is showing here K2 alpha 1 2 is high. In the second case K2 is high, here you can see K2 is high. Okay, so in this case K1 alpha 1 2 is low, so here it is being placed. So now this K2 will be joined with this K2, and K1 will join with this K1. Okay, now let us draw a point over here. If the point is here, so for species 2 it is below, that means this line which is going to increase. Okay, and for species 1 it is above, that means it is going to decrease. So here it will decrease, or it will be, the arrow will be towards opposite side. So here in between it will show the resultant line. So it is showing towards the K2 species. That is the reason here the K2 species is going to win. Species 2 is going to win. Okay, so here it is the same thing for these things, like when there will be stable coexistence and when there will be unstable coexistence. Like from this diagram we are going to see that what will happens if K1 and K2 of both spaces is at higher intercept. Like here you can see that K1 and K2 both are at higher intercept. Like here K2 is high and here K1 is high. What will be the conditions? Okay, so when both the things are high, during that time what happens? There will be unstable coexistence. If one is high and one is low, during that time there will be stable coexistence. Okay, so here you can see the K2 which is present is high in this case, and it is for species 2, and in the species 1 also this K1 is high, and the K2 alpha 1 2 is lower. Here in this y-axis K1 alpha 1 2 is lower. So here we have to join K2 with K2 and K1 with K1. So let us give a point over here and here. So in this case you can see that for this species 2 the point is below the isocline, that is it is going to increase, and for species 1 it is above the isocline, that is it is going to decrease, or it will be towards the opposite direction. So from here the resultant which is going to show is for K2. So it is telling that K2 is winning. So in this case when we see, when we give the point over here, so for species, so for this species for N1, that is the species 1, it is below the isocline. If it is below the isocline, that means it is going to increase. Okay, and here you can see it is above the isocline. If it is above the isocline, that means the arrow is going to decrease, and in between the resultant will take place. So here it is indicating that the K1 is going to win. So in this case both the things are going to win, that means both are having the higher effect. That is the reason it is showing unstable coexistence. It is not stable. Okay. Now let us see the other condition. So here you can see the condition when K1 and K2 both spaces is at lower intercept. Like here you can see that K2 which is present, it is in lower intercept, and K1 which is present, it is also in lower intercept. So when these two things are in lower intercept, during this condition what happens, there is stable coexistence. Like here you can see the K2 is present in lower intercept and this K2 is present in higher intercept. So this things will be joined, and here the K1 is in higher intercept and this K1 will be joined. When we give a point over here, like for this spaces 2 is spaces for spaces 2, it is below the isocline. So here it will increase. So for spaces 1 it is above the isocline, so it will decrease. So it is showing that spaces 1 is going to win. Okay. In this case it is showing that spaces 2 is going it is showing that spaces 2 is going to win. So this you can see the intercept, the resultant which is present, it is facing towards each other. That means it is indicating that both the spaces are at lower intercept, or we can tell that they are weak. So in this condition what happens, they can show the proper stable or the stable coexistence. Okay, so here you can see these things. Like this are the different type of graphs which are present. So in this case what happens, the spaces 2 eliminated. So in this case why the spaces 2 will be eliminated, because in this case the spaces 1 is winning. Like you can see the spaces 1 which is present here, it is in higher intercept, and here also the spaces 1 is in higher intercept. So here the spaces 1 is winning, so spaces 2 is being eliminated. In this case you can see the spaces 2 is winning. Like here the K2 is in higher intercept, and here also the K2 is in higher intercept. That is the reason here the spaces 1 which is present, it will be eliminated, because here the spaces 2 is winning. So in the third case spaces 2 is eliminated. Why? Because here you can see here the K2 is high over here and K2 is high, and here you can see the K1 is high in this condition. Okay, so here there will be, so here here you can see that both the things are being, here both the things are increasing. So here it will show that unstable coexistence. Okay, and in this case you can see that K1 by alpha and K2 by alpha, they both are present and in higher intercept. Okay, so here the K1 by alpha which is present, here it is in this, for the spaces 2 it is present in high, and for spaces 1 it is present, and here so it will show the stable equilibrium, because here the direction of this resultant is facing towards each other. That is the reason it is showing the stable coexistence. This is how the Lotka-Volterra model is working to show which species is going to win and which will show the stable and the unstable coexistence, and who will be eliminated from the spaces. I hope all of these things are clear and you can able to solve the questions. Thank you everyone for watching this video. Thank you.